Hello developers, let's start developing. We're taking on the second task of Advent of Code 2025 today. And this time we have some weirdish input. So this is our input and I'll explain what we need to do. So it doesn't need to be wrapped, it's a single line of text. And basically inside each of these ranges we need to find which numbers are basically not palindromes but which have the same number twice. So 5 twice, 64 twice, 1, 2, 3 twice. There are some optimizations that we can do, but let's try to solve this first and then maybe optimize it. So we're just gonna read a single line here, which means we can do this. So this is not a string array, this is a line. And then we're gonna need to line dot split on a comma, I think. Yeah, we split on a comma. And then we also, then whatever we get, we split on a dash or a minus or whatever you want to call it. And then we can map that every string split on a dash, and then we get some things, and I will just say map them to a number and return that. So which means we're getting each of these, we're splitting on a comma, we're getting one set of this, we're splitting on a dash, so we get the first part. The second part, we're trying to make all the parts in a number, so this would work for this as well. We don't have that case anywhere because it doesn't make sense. So if we're correct, we should get a matrix of numbers. We're not actually getting a matrix of numbers, we're getting an array of ranges. So this doesn't actually do that, it returns a range array. Yeah. This is a tuple, which means that this is a number that actually has exactly two numbers. So this is not sure that it only has two numbers, but I will just say assume that this is a range, and if it's not, then we have a bigger problem. So we're not doing an array of strings, we're doing an array of ranges, so all of these need to be ranges. Yeah, I'm not gonna do any checks on that. In a real scenario I might, but yeah, we can just say, yeah, let's just assume that we have everything that we need. So we need to find how many numbers in each range are duplicates, doubles, or so to say. So we can have a total which is 0, and then we can do a for of loop of the inputs. So for each range of the input, and I'm gonna do a bit of destructuring here, so we're gonna have the start and the end. And now we can just say for something like this, for I don't like using I as a variable, so I will use index, or actually this is the number, the value that we have. So how do we get half of that? And I'm not speaking about halves as a numeric things, I'm speaking about halves as a textual thing. So let's rename this to n value as a numeric value and have the actual value be n value to string. Yep. And now Copilot is suggesting something that so we can have the first half like this. So first of all, if the length of this is odd, then we can just skip it, because an odd number with an odd number of digits cannot be the same number twice. So if it's an odd number, continue. Otherwise, we have the first half, we have the second half, and if the first half is equal to the second half, we are not increasing the total, we are summing up the total. So total plus equals the n value, because we actually want to sum the numbers. And found matching value. Let's just do that, and then we can say return the total. Let's see if this works. We're looping through all of them, we're trying all the numbers literally, and note that depending on the range, for example, all of this range, which could be quite large, have the same start, something like that. Both the start and the end have the same first half. Anyway, let's try to run this. npm, oh, not num, npm start the second task. It found 11, it found 22, then it found 99, 1010, found this thing, that thing, and it says the total sum is exactly this value. Cool. Let's see if this makes sense. Note that we have quite large numbers, so we might have a ridiculously high number of things that we need to check. And I have no idea if that's the case. I will just run this and see if it finishes in any sensible times. So it actually took 211 milliseconds, which sounds sensible, and I would guess that most of that time was actually spent on logging to the console. Let's see if this works. Yeah, now it's a bit shorter. Let's see if this is the correct solution for the first part. It is. Great, we have our third start of a year. But now I guess things will get complicated. There are still invalid IDs. So, if it's made only of some sequence of digits repeated at least twice. So, only, which means it needs to be fully, which means 1, 2, 3, 1, 2, 3, 1, 2 won't be valid, won't be invalid, it will be valid. But 1, 2, 3, 1, 2, 3, 1, 2, 3 is invalid, or this one, or this one. And note that for this one, it's a 1 7 times, which means that that's an odd number. Or here we have 9 digits, which is also an odd number. So now we will need to do some other checks. So for part 2, I will literally, we'll remove the unneeded debug. For part 2, I will start with part 1, but instead of doing this, I will add some const check multiple, which takes a number and returns a boolean. We'll just have a return false for now, and now we have all of these something like that. Yeah, let's rename this to n value so everybody is happy. So this would be our implementation of our check multiple for the first part. Yeah, now it only checks if it's double. Okay, by the way, let's rerun the small input. Let's see if that works. And now I will run the second part as well, hoping that it gives me the same answer for the first part, which is great, which means our refactoring, so to say, is operational. And now I can think how to make this check multiple actually work. So we need to check a few patterns now, not just one. We need to check whether it's all the same. So it can have at least two, which means that we need to check for a length from 1 up to and including half of the length. So if we have 7 digits, we can theoretically have, if it's 7, we can only have a period of 1, basically, because 2 is not divisible, 3 is not divisible, 4 is over the half. But if we have 8, we can have 1, or we can have 2, or we can have 4. And if we have 12 digits, which means we have a period of 1, a period of 2, a period of 3, or a period of 4, or a period of 6. Yeah, so which means now we can say if, yes, exactly this. If the length is not equally divisible, if the full length is not equally divisible to this period, then continue. Otherwise, yeah, we get the segment. And that segment is a part of the value. So now we're gonna actually, let's construct that. Let's create a new string. Now we're talking strings that will be the same segment repeated over and over again. So do we have a repeat? Yeah, we have a repeat. Method in JavaScript. So we can say const target. It's that. And now if target equals to is the same as value, we have our winner. And note that if we have, for example, the number 1111, we just need to check it once. It's gonna be invalid either way. We can count it that it has a period of 1 or a period of 2, but it's still invalid. So return true, otherwise return false. That's all there is. So let's run part 2 for the small input. We're getting 417 something. 417 something ends with 265, ends with 265. Let's actually add the console log here. That would be nice. And let's see if we have a winner. 1122, so we got 111, we got 999. What else we got? We got 21, 21, 21, 21, which I guess we didn't find before. Yeah, because it's 5 21s. And we got it reasonably fast. Let's remove this. Let's go back to the big input. And let's try this once more. This might take a while. But let's see if it's fast enough. Yeah, it took 228 milliseconds, which might be an issue if we do want to optimize this, or if we want everything to run as fast and we want to copy this and we really want to copy this and not the code that produced it, and hope that we have a correct answer. And we do. So we did manage to blast through our second task. But how did we do that? Well, proper separation of concerns, proper breakdown of the problem, and the problem turned to be trivial. There could be much better implementations than this. We do not need to recalculate everything all over again, but sometimes brute force works fast enough and it's easy to understand. This code is not tricky, it doesn't use a lot of variables that we're passing through. Everything is kind of self-contained, and it's easy to work with and it's easy to understand. And that's oftentimes a bigger problem when writing software, having code that you actually understand, than having code that runs fast. So far we have two suboptimal solutions that just work, which is fine by me. So click those buttons, smash those comment, subscribe, like, whatever you want to do, and keep developing.